You guys ready to get going?
Yes.
All right, cool. So before David comes back up here, I'm just going to do a couple other things that I thought could be of use. I want to show you a little bit about scatterplots, and then I'll do one. I'll show you how to do a linear regression in NumPy, and David will then pick up with the stats models library and show you a different library for doing some of these statistics functions. So to start, let's bring that Gapminder data set with all of the Gapminder data into as a data frame. All right. So I'll say I'll call it Gapminder equals pd.read underscore CSV, and it's in my data, Gapminder all. Okay, and I'll just look at the Gapminder.head. So let's create the goal here is going to be to create a scatter plot comparing the GDP per capita, and let's see, what other else do we have here? I think we have life expectancy that we're not seeing. So how can I get what's in those missing columns there? Like it just kind of left out a bunch, right, with a dot, dot, dot. It tells me there's 38 columns, but I don't see them all. How can I see the rest of those? Like, what's one way I could get what the column titles for this are? Yeah, dot columns, right? Dot columns will give me a list of these. So if I say Gapminder dot columns, you see that we also have these values for life expectancy. Okay, we didn't see them in the head, but there are life expectancies. So let's just compare the GDP to the life expectancy for 2007 in a scatter plot. Okay, so to make my plot, first I'm going to create a figure, plt.figure, and then I want to do plt.scatter. Oh, yeah, sorry. Okay. And, you know, I want to refer to columns from my data frame. Like I want what? This column, the GDP per cap 2007, and against the Y value of life expectancy 2007. So how do I refer to this, the column GDP per capita 2007? Well, it's the name of that data frame, Gapminder, box, quotes, and the title, GDP per cap underscore 2007. There's my X. Y, I want Gapminder, box, quotes, lifeexp underscore 2007. Okay, I got an error. Like I was saying, usually these errors are real. This is me making a mistake. What did I do? Oh. Here. Yeah, y'all probably got it, right? But what did it tell me my error is? Yeah, I spelled it wrong. Okay. This is always a killer. Like, you know, a couple of us have run into case sensitivity issues already, right? Yeah, I'm not good at spelling, and I don't have a spell check put in this, so.
Does that exist?
It doesn't exist as something that that Jupyter comes with ready-made, but people have made extensions that you can get that will do spell checks. At least I don't know of it as an existing feature within the Jupyter ecosystem, but I could be wrong. But I do know a guy at Bryn Mawr who wrote an extension for the notebook that you can just grab and do it.
That's pretty sweet.
Yeah, he's very smart. He got tired of his students making all the spelling mistakes because there is no spell check, you know, like.
Asking me why you're getting errors.
Yeah.
No, I just continued. So we started, this is the first thing he did. And he back.
Okay. So, you know, a scatter plot right now, all we can do is we're looking at comparing two variables. However, we can add other layers to this. Like maybe what I want to do is I want to see which continents are where, something like that, all right? Well, I could color these based on that categorical variable. I could color these points based on that just by asking it color equals, and it would be gapminder, and I'll do continent. Right? Every point will be a different color if I do if I do country. So continent will tell me which continent. And okay. What is this error now? C.
C. Mm-hmm.
Okay, here we go, right? Off the cuff. All right, so, why didn't it color these?
It is because
No.
we have alphabetic characters over there. We have to give it some numeric values.
So, to change these to some sort of a number?
Yes.
Okay.
You got it?
Index would be unique.
Yeah. This would take, I mean, I don't know the answer to my question off the top of my head immediately, so I'm not going to waste your time trying to solve this with my own issues here. But I can color, so like, there is an input for color. We can also change this for size, and I believe that size will tell me if I look at size for Gapminder and quotes. So in this one, I'll do the size based on the population. So pop underscore 2007. And this didn't work either. What would you guys do if, oh, there we go. Okay. So it made, let's just ask, what do you think happened when I did that? Like, why is it all red? So it mapped the values to be the size of these points, right? This is population data, so it's probably large. So like it made this huge point that just occupies the whole screen, right? I can, if I make these to be lesser values, it should work. So if these populations are probably in the millions. So if I divide this by 1,000,000 or 10 to the 6th, then I get the sizes, and you can see where the big populations are and the small populations are, right? It's not, nothing has changed there. We've just changed the kind of size of the points themselves to be more appropriate. What do you notice about the data when we look at it now in terms of what we wanted to do? Like, we wanted to look at comparing two variables and maybe doing something like a linear regression. Well, is this a linear pattern?
Not really.
No, right? Can I make it linear?
Maybe you can transform. I don't know. Transform.
Yeah, I can do a log transform on one of these, and I think that will linearize it, right? So we can actually change the scales of the axes pretty quickly and easily with, like, there is a log scale axis. So if I do plt dot x, let's see here. What is the, you know, again, like going off the top of my head, x log, x log. Well, this would be a log, but I don't think I want both of them to be logs. So, you know what I'm going to do? Just Google it. Google. So Matplotlib log axes. That's not what it is. Oh, dot what? Dot x scale. Let's see if the plt dot x scale log. Ah, there we go. Okay. And sure enough, that kind of flattened it out, right? Now we have this, what is not a tight linear relationship, but you know, as one goes up, the other goes up a little bit, right? So we could, again, you saw that there's a log to log both of the pieces of data and so on, and to transform it, okay? Yeah, so the last thing is, what if I want to see how strong this relationship is? If I wanted to use linear regression to explore how these variables are related. So NumPy, there's a number of different ways, a bunch of different libraries that have regression built into it. I'll show you how to do it with NumPy, just because I think it's pretty straightforward. But then stats models is really a more robust library for doing statistics and things. However, you know, we're comparing these two values, right? The life expectancy and the GDP per cap 2007. If I wanted to, I could do, if I want to run a linear regression on those two variables, it's np.linregress. And I just have to enter those variables. And last, it's not np linregress, it's np. Yeah, not doing very well right now. Just 1 second. Let me jog my memory. Linear. Polyfit. Yeah. Sorry, np.polyfit is the right one. Linregress is a different library. And what this is going to do is this is going to fit a polynomial line to our data here. Okay. So I'm telling it, yeah, find me a line of best fit, a polynomial line of best fit between these two variables, and the degree of polynomial I want is degree 1 for linear, right? It's just mx plus b, first degree. So then what's output here? Well, the slope and the intercept of that line. These are the values for the slope and the intercept of this line, okay? And that's a pretty kind of tight, clean entry to get some results from linear regression, okay? This immediately doesn't tell you some of the other important statistics you might want to know. It doesn't tell you about R squared or something like that. However, I think that there is a way with NP Polyfit to get it to spit all of that stuff out. So if I look at the help, and again, like this is just totally how I end up doing this a lot of times, okay? I remember that I can do it. I remember there's some sort of keyword in there to do it, but I don't remember exactly what that keyword is. So look at the help, and sure enough, full equals false is the default kind of output of this, which means that it doesn't give you the full results of the regression. But if I change this, then it will show me everything. So let's compare what I get if I include a full equals true in my call here. So 1 full equals true. And now I think I get residuals, I think I get standard error, I think I get slope intercept, and I think I get an R² value. Stats models is much better because it shows you exactly what these values are. Like if you're used to maybe some of the output of R or something like that, it will tell you like, oh, this is R² and so on. This is a little bit cryptic still with what's what. But yeah, so if I wanted to try a quadratic fit or something like that, I could just change this to 2. Now, did I actually fit a line to this graph, like to this data?
No.
No, right? Because I had transformed this. So actually what I wanted to do was to look at the log of one of these guys, right? So I would have to just take the logarithm of one of those values to be doing a linear regression on this guy. And then I would have to plot the results of that as well, okay? But, yeah, this is the slope and the intercept of that line of best fit for a linear function not fitted on the log transform there.
Which one is R² out there?
Which one is R²?
Yeah.
I believe it's the last value here. This one is incredibly small, but that's not really indicative of much in this example. Yeah.
Why is there a 1 after in your original line of code?
Oh, because polyfit is saying like it's just it's a polynomial fit. So it could be a quadratic, it could be a cubic. I have to tell it what degree polynomial to fit this to. So like before, right? We had this thing def f of x return x², right? And if I say a equals 1, 2, 3, 4, something like this, and I say PLT. I'll draw a plot of this. Oops. A f of a. It's not the right way to do that. A. 0 to 4, 5. PLT A, f of a. All right, so like now I have, right, I have these points like in a different kind of pattern. Like this is quadratic, right? So if I see this and I want to fit a line to this, well, I would use polyfit, except for I would say fit a second degree polynomial because it looks like there's a quadratic pattern here. So to fit something to this, like I would write np.polyfit, and I would say a f of a 2. And you see now, right, I get 3 numbers back. Those 3 numbers are the coefficients of your quadratic polynomial, ax² plus bx plus c. And sure enough, if you wanted to make a function with these values as the values of the coefficient, you would get a line that goes perfectly through here. Right? Or just about, actually. This isn't perfect because we know what this is. This is just x², right? And it's actually showing you that there's very small values for those other guys. These should actually be 0, right? And this is just 1, as it should be. But there is some error in it. These aren't perfect, okay? The equation for that is just y equals x². You know? How do we know that? Well, we defined it. Okay. So that's the NumPy Polyfit. If you wanted to plot these, there's another thing called polyval that will evaluate the polynomial there. But those two things together, you can use NP Polyfit and NP Polyval to just do some very quick and easy regressions and plot the results. Okay? Yeah, the other thing that I wanted to show you is to include different kinds of variables within the scatter plot, but I think I'm confusing the categorical coloring with R here. I don't know if, David, if I'm doing this scatter plot, how do I color those points based on a category?
So yes, you can do that. Typically when I've done it is I would do like a loop with if statements, or you can do like a conditional, like a lambda function or something, and then you would break down the categories, or you can define them in a loop and then apply them. There's many ways, but I think it's not worth this.
Yeah.
It's a little complicated.
It's, yeah, in R you can just say, oh, here's this, like color it based on a category, and it will parse those and break them apart. Matplotlib is not quite behave the same.
It's much easier in CBOR.
Yeah, yeah.
But just visual-wise, you cannot change some part of portion can change colors, upon it,
So it'd be based on the criteria. So say you
Yeah.
had like ages greater than 50 years
Yeah,
old and
yeah,
ages less than
yeah,
50 years
yeah.
old, she can make some red and some blue.
Yeah,
Yeah.
I can.
You can.
Okay.
You just have to look up the exact code for you.
So like, yeah, the color is like C will change the color, right? Like I changed the color of this to be green. Something else I could do is I could just make a plot for each of them and color them all.
Different color, 60, the 60, on the left side, yeah, there's a different color over there. And lower is maybe different color, whatever, so you change the colors.
Okay, so I'm going to put up a link from Stack Overflow that shows you an example
That's
of
okay.
what to do.
No, I just want to change
No,
the
no,
color.
I'm actually going to, yeah, it's going to be actually what you want. So here,
You're saying to change like a subset of this to a
Yes,
certain
yes,
color.
yes.
Yeah, yeah.
hey,
The-
Jacob, open it up on the Etherpad. I'm just putting one on. It's should appear. Let's see. Coloring Matplotlib scatterplots. That's right there. It's just an example, and you can scroll down and see how with NumPy and pandas you can do certain things. So it's possible. Generally, you set different axes, and you set your data sets. But there's many ways to do it. This is one way that can work.
Yeah, maybe the most straightforward is to, like, if I'm doing a plot here, instead of looking at A and f of A, like I could do, I could plot the first part of that by slicing that list, plt.plot, like A just through 2, and f of A through 2, and let that be blue or something. And then take the other part of it and let that be something else. So like take the rest of the list.
Yes, you could plot them each separate, and then, yeah.
So like 2 forward, f of A.
That's actually a very, very common technique in machine learning for separating data to like see the comparisons, or like A/B testing.
Yeah.
See, so it's 2 different colors, but I mean, this isn't the way that you would want to solve that problem with the gapminder data necessarily. I mean, like you would write something that would parse it that way and then input the results of that into the coloring. But yeah, and you can, again, like you can plot a whole bunch of different things on the same set of axes here.
And just take a look at the link I sent, because I know Jacob only got to look at the higher part, but there's like many examples on that link, or if you wanna scroll down, Jacob, there's like many different examples of ways to do it with NumPy and pandas. So you can like get a sense on like what do you think's interesting, or like there they have, that's it.
Yeah, the pair plot is a nice piece of Seaborn. Yeah. Bokeh,
There's like many ways to do it, that's,
yeah, yeah.
and who's ready for statistics?